Hello and welcome to the section 12.2 lecture today. Today we're going to be looking at the converse of the Pythagorean theorem. When it comes to geometric theorems that this one falls into, it's one of the most well-known theorems. That's why it's the first one we're talking about. Typically the converse is not something that's necessarily useful. But in this case, it ends up being that it is. So if we remember Pythagorean theorem, it said that if we have a right triangle, then a squared plus b squared plus a squared plus b squared equals c squared is true, right? Now we're talking about if a squared plus b squared plus b squared equals c squared, then it's a right triangle. So it's that causality thing. It's that if-then type of relationship. And in this case, it just happens to go both directions. But it actually tells us some more information as well. So not only do I know this line, that's very important to know, but I also know that if c squared ends up being smaller than a squared and b squared, then the triangle would be an acute triangle. All the angles would be less than 90 degrees. If c squared is greater than a squared plus b squared, then the triangle has an obtuse angle, has an angle over 90 degrees. And this kind of makes sense, or I guess a way to visualize it. It doesn't actually work this way. But if you think about, I've always thought of it more of the angle than the sides, because that's kind of what we're talking about. We're talking about how big is this c angle. If c squared is smaller, that means that this side never got long enough, this c side never got long enough to make this angle a right angle. Okay, and then if c squared is bigger, if c is really big, I always thought of that side being really big, and so there was guaranteed that this angle here would be over 90 degrees. And that's kind of the best way that I had to sort of visualize it. So let's go ahead and try to put that to use. We want to figure out if each one of these triangles is acute, right, or obtuse, based on these three statements right here. So we always have to think of which side is the longest side. 10, okay, 12 is bigger than 10. So right now 12 is my proposed hypotenuse, but I'm worried about this square root of 42. So maybe I check out the square root of 42. Okay, it's 6.5, basically. Okay, it's basically 6.5. So the longest side is 12. I want to figure out if this gives me a right triangle or whatever it gives me. So the first thing I do is I take the longest side and I square it. And I'm trying to relate that to the other two sides squared and added together. We have square root of 42, and I want to square that. Now, you could try this, and I have square root of 42. I had it. I don't have it anymore. Let me just grab it real quick. So I have the square root of 42. Now if I square that, I get 42 again. And that's a common thing in math, that squaring and square rooting undo each other. So anytime you have a square root in this answer, it's kind of nice to square it. But I would really urge you to go ahead and use a calculator there. Find out what that side really is. I could have used the 6.5 just as easy. So I rounded that to 6.5, and if I square that, I get 42.25. So a little bit bigger than 42, but it shouldn't be enough to matter. It should be really easy to tell. So 12 squared is 144. 10 squared is 100, and we just talked that the square root of 42 squared is 42. And then 10 plus 42 is 142. So c squared is bigger. So that brings in this last line where c squared was bigger, So that means this is an obtuse triangle. Maybe not by much, but it is not a right triangle. It's obtuse. Okay. So let's look at that kind of other method of doing it in this next one. I'm just going to figure out what is 4 times the square root of 5. That's kind of tough because I have to do square root of 5 first and then multiply it by 4. And I am going to round here. I'm going to leave a couple places here. We're going to say 8.944. That's what we're going to use for this. So let's say that this is 8.944 because I'm going to have to square that, and I want to know really close to how big that is. So anyways, looking at that, that tells me that 12 is my longest side. So I'm going to look at 12 squared versus 8 squared plus 8.944 squared. Oops. Now, I would be better off just to use this and square it. Okay, there's no doubt that that would be a better solution. We're going to see what happens if we don't. We're going to say we rounded it to 8.944. Let's go ahead and square that. And if I round this, it's going to round up to 80. If I want to keep those 3 decimal places, it's 79.995. And then 8 squared is 64. 12 squared again is 144. So let me look at this side. Let's say 64 plus 79.995. The 143.995. At that point, I might go back and I might check, well, what happens if I take this how it's written? So 5 square root of 5 times 4. And then square it, I do actually get 80. So this does actually round up to 80, making, when I add these, making them equal 144. And since this side is also 144, those two are equal. This is a right triangle. Most of the time that we won't get a right triangle, it's going to be at least this obvious, right? That it's a couple numbers off. This one, when I rounded it and kept some numbers in there, it ended up being just a fraction off. I'm not usually going to pick on problems that are that close and still don't make it. In the next one here, and I don't really want to trust the picture, I want to get a feel for how big these numbers are. So I'm going to grab my calculator and look at 197 as a square root, and it's 14 point, let's say 036, just to keep 3 numbers. Oops, 14.036. And then 180, and I square root that, 13.416. 13.416. And so just looking at my general sizes here, 4 and 13 are my smaller two. So let's take our 14.036 and compare that to the other two squared and added together. 4 squared plus 13.416 squared. That's going to run over into the other one a little bit, but that's okay. Let's use our rounded decimals. Oops. 13.416. I'll just multiply it by itself. And that's feeling like it's about 180. Okay, it's pretty dang close. And I'll bet, I would probably look at it here. I would look at, that came from, oh yeah, I guess I'm working a little too hard here. 180 square root and then squared. Sorry, don't look at what time it is either. Yeah, trying to get this done. It is 180. So this is 180. 4 squared is 16. And this squared, I don't want to work too hard there either. It's going to be 197. It's the square root of 197 then squared. Okay. And so when we look here, and there was actually no rounding at the end of the day, there's no rounding that happens here. This is 196, this is 197, so that means that the C value was bigger, C squared was bigger than A squared plus B squared. That means it's another obtuse triangle. Okay, check the references up above. I guess the only time that we really get in trouble with squaring our square roots is when there's a number in front like this one had. But still, we would like to see about how big they are so that we can guarantee which one is my hypotenuse or my proposed hypotenuse. So we're going to look at 290, look at its square root. It's about 17, and we'll look at 70, look at its square root. It's 8. So I have 8, 15, 17. So this one is going to be my hypotenuse, and so let's go ahead and work with that. So we're going to look at the square root of 290 squared. I don't want to write equals because I don't know if it does. And compare that to 15 squared plus 7, square root of 70 squared. Square root of 290 squared is 290. 15 squared is 225. And square root of 70 squared is 70. So when I add these two together, I get 295. And so the a squared plus b squared is bigger. And if I look back up here, when the a squared plus b squared is bigger, that means it's an acute triangle. Again, that C value, this value here, didn't open far enough, didn't make the angle open far enough to make it a right angle. It's going to be acute. All right, all the angles are less than 90 degrees. These ones, whenever I write 3 in a row, it's always going to be that the last one is the longest one. And that's because this is about, gosh, not by much, I guess. Let's just figure it out. My brain's not working. 74 square root, that's what I was thinking. And it's about 17. Okay. Actually, I do want to know 17.205. Let's treat it like that. Because squaring it with that 2 in front doesn't work out too well. It will, but there's a little bit lacking there. So I want to check, I'm going to write it the same way I have been, 17.205, and I'm going to square that. And I want to compare that to 10 squared plus 14 squared. Well, let's work on this side first. 10 squared is 100. 14 squared, you can go ahead and check my work. It's 196. And then 17.205, I still have it in here. I might as well just square it. I get 296. And it turns out that those are equal. Oops. Those are equal, and that gives me a right triangle. And for the last one, 11 is the biggest. Square root of 35 is almost 6. So I have a 9, a 6. I don't know why those two wouldn't be switched, but that's okay. A 9, an almost 6, and an 11. So the 11 is the biggest one. So we'll check that. Compared to the square root of 35 squared plus 9 squared. 11 squared is 121. Square root of 35 squared is 35. 9 squared is 81. 35 and 81. Looks like 116. Yeah, I believe that. Yeah, 116. So the C squared is bigger, and that tells us obtuse. All right, make sure you put any questions you have over on the left. Otherwise, I hope you have a great day, and we will see you in class.